Okay, in this lesson we're going to do some right triangle trigonometry. We're going to solve some problems with trigonometry of right triangles. Now, some of you most of you should be really familiar with the Pythagorean Theorem. It's the fundamental right triangle equation, a squared plus b squared equals c squared. But it comes out of sort of a standard diagram of what a right triangle, a generic right triangle, looks like. And this, I have triangle ABC, where C is the right angle, and across from angle C is this little c here stands for the length of the side between A and B. So the angle and the side names are opposite. So that's why C is the hypotenuse here, and it's also the right angle. So angle A, side A. Angle B, side B. And that's just the way that the naming of right triangles is easy, and actually all triangles is easy to sort of keep track of, that the side name is opposite the angle. And we use a lowercase for the side length and an uppercase for the angle. And so let's go ahead and do that here. Let's use that. Here we got a picture. It's a right triangle. I already have two sides, which means I don't need to do this new trig stuff. I can use that classic old Pythagorean Theorem to solve. So here we go. Let's plug it in. So that looks like A is 6, so 6 squared. B down here we don't know, so plus b squared is equal to c 10 squared. So 6 squared is 36 plus b squared equals 10 squared is 100. I'm going to subtract 36 from both sides and I'll get b squared is equal to 64. And then you take the square root of both of those pieces and you would get b is 8. So this side here is 8. So in this information I'm going to put in, hey, side A is 6, side B is 8 because it's opposite B, side C is 10, and that's going to help me out as we move forward. Now, I'm going to actually in this problem do all the trigonometric ratios. So I'm going to do the sine of A, cosine of A, tangent of A. I'm going to do the sine of B, cosine of B, tangent of B. And you'll hopefully see some connections. Okay, so the sine of A, and remember, sine is opposite, so here's A, opposite is A over hypotenuse. Opposite over hypotenuse. So I take the opposite, which is 6 over 10, but I got to reduce that. So 6 over 10 reduces to 3/5. So the sine of A is 3/5. Cosine of A. Cosine here is B over C. It's the adjacent one, is the one that's connected to that angle, except for that, not the hypotenuse, that's got its own name, but the one connected to that angle over the hypotenuse. So we would get 8 over 10, the adjacent over the hypotenuse, 8 over 10, which reduces to 4/5. Okay, and then finally tangent. Tangent, see, it's A over B is opposite one, the one that's opposite, divided by the adjacent one. So in this case, it's 6 over 8, which also reduces to 3 over 4. Okay. Now I would like you to actually pause this video, and I'm going to write the answers up here. So go ahead and pause now, and when you resume those, I'm going to have these answers written so fast, like while it's paused. All right, go. Pause. Okay, there we go. So if you figure these ones out and reduce them, you should have gotten 4/5 for the sine of B, 3/5 for the cosine of B, and then 4/3 for the tangent of B. Hopefully you can see that there's some connections here. The sine of A and the cosine of B are the same. So if you take the sine of one of the non-right angles, remember we're not ever dealing with this one when we're doing trigonometric ratios. So if you do the sine of one of them, it's equal to the cosine of the other, and vice versa. If you find the sine of this one, it's the cosine of that one. And then with the tangent, they're just inverses. They're just reciprocals. So 3/4 here for A, 4/3 for B. So once really you find these out, And I just smashed those through. Once you find these out, it's pretty easy to find those out. You don't need to actually rework the problem. You can just flip those around and then invert that one. And that's all you need to do. Okay, now last we're going to find the angle. And here's how that works. So if the sine of A is A over C, or opposite over hypotenuse, then what we say, we have to come up with new language in order to solve this problem. We say that A is equal to the sine inverse of A over C. So in this case, the measure of angle A is equal to the sine inverse of A over C is 3/5. And then we've got to use our calculators because for most of these problems it's literally impossible to just memorize everything, every possible combination here. But this is something that you're going to type in your calculator. There is a sine inverse button, and you do the sine inverse of 3/5. Make sure to put parentheses around the 3/5, and then hit enter, and you'll get an angle. And we'll do that here right at the end. I'll write up the angles. So once again, why don't you pause, and I'll pause, and when I come back, the angle measures will be written up for all three. Except for this one, you should already know, is 90. All right, pause, go. All right, so if you were able to get that the measure of angle A is 36.9 degrees, and the measure of angle B is 53.1 degrees, you're on the right track. Now you'll notice I didn't actually even use the same formula for either one. It's really up to you. I did the sine inverse of 3/5 because the sine of A is 3/5, so I did the sine inverse of 3/5 to find A. But I could have done the cosine inverse of 4/5 to find A, or the tangent inverse of 3/4 to find A. Either one would have given me all the same answer. So for B, I chose to do the tangent inverse of 4/3. The tangent of B is 4/3, so if I want to find B, I did the tangent inverse of 4/3, type on my calculator, making sure that my calculator is in degree mode. There's another mode called radians that you want to avoid for this course. Later on, you'll see that again, but right now you want to be in degrees. And of course, here we have the 90-degree angle. Now, if you add all these up, they add up to 180, which is another way to check to make sure you did it correctly. If all your solutions add up to 180 degrees, you're on the right track. All right, now, I'm not going to do this problem, but I want you to figure out all the information. I'm going to solve it right at the end. You're going to see the answers, but I'm not going to show you how in this video. You can ask me in class. This is your challenge to see if you can figure out what are the rest of the angles in this shape and what are the measure of the sides. All right, get to it. All right, if you've got 60 degrees, the hypotenuse of 10, and the other leg at 8.66, or if you know the special rules with 30, 60, 90 triangles, you would get 5√3. Again, you can ask me about this in class if you don't get that. All right.